In this video, I'm going to have an R script read in a JSON file from the internet. I made one previously, and this is a companion to it. So in the previous video, I read data that was about planets, and within the JSON notation, it started with a square bracket, meaning that the entire thing, the entire data was an array, and then the curly brackets are objects. So it was an array of objects. And this time I want to work with a file that has overall mostly the same structure, but starts differently. So it's going to start with an object that object is going to have a property. In this case, I'm doing US GDPs, and then it's the array. So before we started here at this array, but now we're starting with an object that has a property, and then that property is an array. So that will bring in some changes, and we'll see how to handle those changes. Okay. So here we go. So bringing in the rjson library, and if you don't have it the first time, you're going to have to install it. Oh, and here's where I got my data from, macro trends. All right, and so I'm bringing in the library and I'm reading in the data using the from JSON method, and that's going to create a list. Okay. And this list is kind of, I don't know, like threefold, or if I'm giving it indices, and I want to get to a particular component, I would need three indices. First, there's a list that has a single thing in it. And that is just that overall object with one property that was in the JSON. Then we have the next sort of list down is there are 61 of them, and they are this data was years of GDP data, and there were 61 years of data. And then for each year, there is the year, the GDP, the per capita GDP, and a percentage growth. Okay, so that's what we got in. And then the last time I talked about, I like to work with, data frames. And I had trouble when I just tried to do a simple cast to a data frame. It kind of wreaked havoc. So what I did the last time was I knew, knowing a little bit about the structure, I converted it to a matrix, and then I used the matrix to create a data frame from that. And I'm going to do the same, except I'm going to have to add to get into this, again, because of this addition in the JSON file to almost everything I had before. I'm going to have to add, when I'm dealing with the list, a square bracket 1 in the front. So here I am making a matrix. Here's how many rows I want, and here's how many columns I want. And the last time I didn't have this, I had only one of these square bracket ones, and I didn't have it here. That's the addition. That's the big change, is that addition means every time I work with this original list, I'm going to have, compared to what I had before, if you've seen that video, I'm going to have a square bracket 1 in the front. So I set up a matrix that is 61 rows and 4 columns, and I'm doing a nested loop, and I'm getting the, again, there's only, the first index is always a 1, then I have an I and a J index, and I'm making a matrix out of that. Okay. And then the matrix is a simpler structure these I's and J's. When you have a JSON list, I can have different named properties, different number properties for each object. I don't, but I could have. But I know that it has a sort of a uniform structure, so I can turn it into a matrix and then use the matrix to turn it into a data frame. And then when I do that, I lose the names of my properties, but I can get them back. So I've made my new data frame GDPs 2, and I get the names of my properties back by doing this. Find the names I had in that list and apply them to my now data frame. So I'm going to apply all this, and I'll have a matrix, which I'm not going to do anything with, and I will have a data frame, and that's what I'm after, a data frame. So let me run that. Okay, so now I have GDP2. It is a data frame. It is a data frame with 61 observations of 4 variables. That's what I was working towards getting. That's what I want. That's what I want to do some plotting and so on, and I like data frames. That's what I'm used to working with. All right, now I'm going to work with the per capita data and the years. That's what I'm going to make a plot of. This data is not a simple number. I want to get it into a number form in order to plot. And so the first thing I need to do is get rid of the $sign, the comma, and I'm down here with per capita. I want to get rid of the $sign, the comma, and then there's a space here. So that's the job of this line 21. I'm using the gsub method. I'm looking for a regular expression, and I'm looking to get I'm looking for $signs and commas and spaces, and I'm replacing them with nothing. And so that was the job of that. Let's run that. We'll see this per capita line should get rid of the $signs, the commas, and the spaces. There we go. And now I am going to use as.numeric and convert them. And then this should change from character to number. And so now I have them as numbers, and I want to do the same down here for years. So I'm using as.numeric on the year field. And then I'm going to fit to a polynomial this data, but I decided I didn't want to work with the years, which are already large numbers, 1960 and on. And so I've decided that I want to work with years since 1960. So I wanted to do a subtraction. So I am here adding a new field. So right now I have my data frame is 61 observations of 4 variables. When I perform line 27 here, I'm going to introduce a new variable, which is going to be the year minus 1960. So I will have 61 observations of 5 variables. And then we see here it's starting with a recent year in the data 2021, and that will go, I'll subtract from that 1960. So I'm going to get 61, I believe. Okay, so here is the year since 1960, and I know I made it an obnoxious name with spaces, which I shouldn't have done because I don't like spaces and names, but I did, so I'll have to deal with that. But there's now a number 61 and a number per capita, and those are the fields I want to plot. So here I am plotting it. I'm going to make a plot, GDP S2, that is my data frame. $sign allows me to get a field from the data frame because it has now I have the 2 names. The per capita were their names from, that space wasn't me, but this space was me. But since I already had spaces, I left with spaces, but I have to do these tick marks. And actually, if I type GDP S2, if I run what's above and I type the $sign, it'll give me options And so it will sort of type those tick marks for me. Okay. And so I'm using the sort of the tilde notation. And so it is y then x. So if I use a comma notation, then I have to do x comma y. But I'm using the tilde notation, so my y comes first. So my y-axis is going to be per capita. My x-axis is going to be years since 1960. I gave it a title. I didn't have any good title for this. I just called it fiscal stuff. The label for the x-axis is years since 1960. The y-axis label is US GDP per capita. Okay, so make the plot. There we go. I'm going to fit this. This looks a little bit more than linear, so I'm going to fit it to a quadratic. So I'm going to use LM for the linear model. My y-axis is the per capita. I'm going to use as my x's not only the years since 1960, but also this I parenthesis a GDPS2 $ years since 1960 with the tick marks _2. So I'm going to have a square term, a quadratic term in my fit, and then I'm going to make a summary of that. So down here I get all of the results of my summary. And I like to always print out a summary because when I start extracting the coefficients from my fit, what I see down here in the summary is what I have to match here. So this guy is what I called the ax squared, the coefficient of the square term. So I just called it A and I used GDP underscore fit $ coefficient square bracket, and then I had to match this. That got me A. If I match this, it got me the B, which is the linear term. And if I match intercept, it gives me the constant term, which I called C. And then I'm going to use the curve method, and I'm going to plot the function. I want the variable to be x. It's ax squared plus bx plus c. I'm going from 0 to, I went up to 62. It was 61, but 62 will do. I'm adding it to what I already have, and I'm making it the color blue. So there is my fit, except a couple years here and there. It's a pretty good fit. And now I want to display the equation on this graph as well. So often these numbers end up with a lot of decimal places that I don't want when I'm displaying. So I'm going to round them all to 2 places. And then I'm going to put together the equation of y equals, I'm using paste. So I'm just concatenating together the equation. Y equals a, the coefficient a times x squared plus b times x plus c. So I'm making the equation. Oops. Sorry about that. Undo. Run that, paste. And now I've created the equation, and now I'm going to use text to put it on. It's an x and a y, so x is going to be about 20. The y is going to be about 50,000, which is in here. So I should see in this vicinity my displayed equation. And there it is. If I make it a little bit, okay, there's I can see the y if I stretch it out a little bit. And that's what I wanted to show. So I was mainly interested in, again, this other type of JSON that one often sees. The previous JSON, the previous video started with array, started with square bracket. This JSON I'm dealing with here started with curly bracket, started with object. That object had a property. That property, then the value of that property was, then the array started. So that was my main purpose of all that. And what that got is what I get in from the JSON is a list. And compared to the previous version, every time I'm working with the list, I need this square bracket 1 in the beginning of everything I had before to deal with this additional level in the list. Okay, that's what I wanted to show you. Thanks much for your attention.